Hello. So it looks like we're live. So this time around, I figured I would do a quick stream on the LXD release we just made. So LXD 4.7, we released it yesterday, and it should be running out to most users early next week. I also just published the release announcement now on the forum. So there's quite a lot in this release. Like we've added a lot of stuff, and I wanted to kind of go through it and whenever possible show the different new features. All right, so I'm running, like I'm on my laptop here, and using local LXD for a bunch of containers. Let's just clean things up a tiny bit. Make it tidier. Yeah, get rid of those two. Alrighty, so the first new feature of LXD 4.7 is around backups. We've had backups in the sense of import and export of instances for a while. But now we've added the same ability on top of storage volumes, and we've also added the ability to import an existing container snapshot or instance snapshot under a different name. So first thing we'll do is we're going to be creating a new storage volume. So my storage pool is called default. We're just going to be calling that blah. All right, so we've got that volume created now. Let's just export it. So that's, oops, that was not possible before. We export it, and we now have a extremely tiny backup because, well, there's nothing in it, but that's the gist of it. We can now delete that particular volume, and we can import it back. So we just do import tarball, and we're back. So we can see that blah is now created again. On the container side, so as mentioned, we can create those backups, and we've been able to do that for a while. So in this case, I'll just create a new container, and let's actually make things slightly more interesting. Also create a snapshot of it. So there we go. Now if we look, got a container with a snapshot, and we can export it. Again, so far nothing new. That's been working for a while. We can see we've got a backup generated again. And normally you would import it just like that, and it would come back as A1. In this case, it wouldn't work because it still exists and we haven't lost it, but we can import it. Oops, sorry, if I do import, it will work better. And we'll import it as A2. And then we can see we've got A1, A2, and A2 also has a snapshot and was just recreated the exact same way it was. So that's a tiny change, but nice improvement around the way backups work. Third is around virtual machines. So that's we've done quite a few improvements around that. And the first one we have is memory management. So let's look at what we have here. We can see I'm running, the only virtual machine that's running on my laptop right now is an Ubuntu desktop virtual machine. I could actually go and show you Ubuntu desktop. So get a graphical console on it and just move that here. Come on. There we go. So yeah, that's an Ubuntu desktop virtual machine, nothing too fancy. Now, if I go inside it and we look at the terminal. Okay, let's full screen this thing, zoom it a bit. We're gonna see that VM has 2 gigs of RAM right now. Okay. Let's go back to our terminal, and we can confirm that by just going to look at the virtual machine and looking for memory. Indeed, it's got 2 gigs of RAM. Well, what if we wanted to have less than that? How about 1.5? Limits memory, sorry. Okay. Let's do it twice. And now let's go back to the virtual machine and see what we have. And we're down to 1.5 gigs. Okay, so that works. And now we can bring it back up, back to 2 gigs. And there we go. You might have noticed that the first time around it failed. That can happen. The way this is handled is the balloon that's inside the virtual machine is inflated to force the virtual machine to release its memory. The speed at which that happens depends on the operating system and how much stuff is in memory. So the first time around it didn't succeed. It got most of the way there. We were still missing a few megs. So you can run it a second time, which forces it to actually reach the target size in this case. And then once you've reduced your memory, you can bring it back up to the previous value. You can't actually add more memory than you had before, but you can at least restore it back to that level. So it's a good way. You could easily use that to set a small limit to force VMs to release their memory and then bring it back up. The most extreme would be to set the memory to 1 meg, which you know is going to fail, but it's still going to have tried to release pretty much as much memory as it can. That being said, some systems might crash if you do that, so maybe try a higher value. And we can also see just what happens if we try to go above the limit. It does state that you can only increase memory past the boot value by stopping the VM and restarting. The other thing that we've added for virtual machines is USB. This particular VM, I don't believe, has anything connected to USB right now. It does not. But we can definitely change that. So let's just stop it. I'm also going to clean up its config a bit because, as you can see, it was used for development. So it's got a few debug things enabled. I just turned that off. Okay. All right, so that's a bit cleaner. It's got just 2 CPUs, 2 gigs of RAM, nothing special. So let's add, well, first of all, I need to plug something. Let's plug this. Okay. So what I'm doing here is I'm plugging a Wacom digitizer tablet-y thing into my laptop. So that's ready. Now if I look on my laptop itself, we can find there's a Wacom tablet in the list, and there. It's like the second at the bottom. There we go. And now we can do device add Ubuntu desktop. Let's call it Wacom. It's a USB device. The vendor ID is 056A. The product ID is 0376. Okay. And start the VM backup. Let's get that. Where's that console? Nothing. Okay. Oh, it was in the other terminal. That's why. Okay. Let's just reattach to that console again. While it's booting, we can already go and see using LXD exec what's going on inside there. So if we go in that virtual machine, we can see the Wacom tablet is directly attached to it at this point. And if we go back to that session here, log in. We should end up with a pretty weird experience where I can actually use the USB tablet I've connected as an input device on the VM. Not sure whether the cursor will record. That's always been a bit of an issue when doing live streaming and everything, but we'll see. Yeah, there you go. You can see that there's like a weird input device that's showing up, which is actually, let's see if I can get this in shot somehow. That's here, that external USB input device. So that's pretty neat. And that works the exact same way as it does containers. But we also pushed it one step further because, as you can see, we already have integration with Spice, with the agent, and all of that going on. So we've also added the ability to live attach USB devices. That's what you can get here in the Spice client. You can do USB and then go and click on something. Let's pick the built-in webcam on my laptop. Okay, that seems to have worked. Now, let's look. Well, we can look inside the VM, I guess. Let's just get the terminal inside there. Yeah. And see what we have on the USB bus. And we can see both the Wacom tablet that we manually added directly to the config, and now an extra webcam has also been added. I suppose there must be some webcam test website we can quickly use to show that it works. Let's just see if we can start Firefox quickly in there. Okay. Yeah, I guess just use this thing. Oh, looks like I used the the second one before, but yeah, let's maybe use the other one. Let's use this thing. What's it doing? Oh, there we go. Integrated webcam. Do you want to share? Yes. And here we go. So that's my another webcam on my laptop. I should be able to go and like wave at it here, which is passed through Spice from my laptop to, in this case, the LXD server, which also sits on my laptop, and then attached to the virtual machine. The thing that's quite exciting with this feature is that unlike directly attaching a LXD device, which always works locally to where the LXD daemon is running, this pass-through through Spice works from wherever you're running the Spice client. So you can totally have the worst case scenario would be you actually have a LXD server or LXD cluster running in the cloud. You add it as a LXD remote and you connect from your laptop to it with the remote VGA console, and then you can pass a local USB device to that LXD instance running on a remote server. Whether it's going to work well or not will really depend on the USB device. I would not try to do that with a microphone or a webcam because the latency might become a problem. But for, I don't know, some like test equipment that just does some measurement or something and has like a USB serial type adapter, that should work just fine. And that's definitely a pretty neat new feature that we've got, that we managed to build on top of the USB support we've added. Okay, just get my bearings. Now the next thing we've added, I don't think it's particularly worth demonstrating, is rsync compression. So we've supported rsync and rsync compression in LXD migration for a while already. That works just fine. If both servers are capable of doing compression, they will pass the right arguments to LXD to compress the migration stream that goes between them. What we've noticed is a few users run into situations where their network is fast enough that compression becomes the bottleneck. Effectively, their CPU is just melting on the source side, trying to compress things, and the network is barely used as a result of it. So we've got a new option we can turn on storage pools that will turn off rsync compression, even if the server support it, so that you will use more. The total amount of data will be larger, but you might get a higher throughput just by not needing to compress it, and so a shorter migration time. The rest of the bits we've added are all tying into oven and networking. So the goal we have with the LXD network and LXD networking project specifically that we've been doing for a while is being able to run a remote cluster with multiple people interacting with it. Each of those would get their own LXD project. And within that LXD project, you'd be able to create your own instances, manage your own images, own profiles, your own networks, and have quotas and restrictions applied to your project that you can't easily escape, which allows for a nice shared environment. One of the and we've got all of that working quite well. And with LXD 4.6, we had support for the network bits we needed. So we were able to create projects with their own network that they could create on demand using Oven. The thing we couldn't do was, well, a few things we couldn't do. One was we needed an underlying bridge to use as an uplink for those networks. That was just a bit unnecessary and using some more resources than we really needed to. So we've changed that, and the first thing we've added is the physical network type. So that lets you create a network. I can show it. Let me just close this guy. Okay. So if we look at the networks on my machine, whoops, that's a projects. I meant network. If I look at the networks on my machine, we see that I've got a network called external here. If we do show on this one, we see it is an actual LXD managed network of physical type, and this one stores what my gateway is in CIDR format, so that you know what the mask is and the entire subnet, and a range of address that can be consumed by Oven. So in this case, from 100 to 150 is the range we've set there, and what the parent network device is. One thing worth keeping in mind is that you do need an actual dedicated device for that. Like you can't have any configuration on it. And it also supports using VLANs. So you could have a dedicated network interface that connects to your underlying network or a VLAN on it. With you configure your gateway, your favorite DNS servers, and what range of address can be safely used on that uplink interface. Then you can create other networks on top of that, which use it as their uplink, and LXD will automatically pick an address in the range you've configured, and will configure Oven to use the right gateway and the right DNS servers for the instances running on it. So that was a pretty important piece to get together. Then kind of one step further on top of that, we've added the ability on a LXD project to restrict it to a given set of uplinks. Rather than doing a lot of talking, I can actually show what we're running. Remote switch and project switch into LXD. Okay. So what I did now is I'm switching to a test cluster that we have, we've shared with some people in the company. That does have multiple projects, so I can actually show that. In my case, I'm a unprivileged user effectively of that cluster. I don't have full admin access or anything. I believe I actually have a separate remote that does have admin access. Just have called cluster admin. Yeah. So cluster admin, both of them are the same cluster. Cluster admin, as you can see, has the default project. The other ones does not. We see multiple projects, and if we go look at, say, the Ubuntu LXD project I switched to, we can see it's got all the features enabled. It's got a limit on the number of containers, CPU that can be used. It's got some amount of disk space and memory that it's restricted to, some amount of processes, total processes you can run. And it uses restricted mode, which prevents me from doing things like creating privileged containers or accessing host devices or a lot of other potentially dangerous things. It also, so in exceptions to that rule is that it's allowing container nesting. So the nested bit, security nesting on containers. And it's also allowing, it's using that new restriction we have, which sets what uplinks can be used. So if we look at the networks, so in the default project, on the cluster admin remote, because otherwise I'm not allowed to do this. Yeah, that shows a bunch of physical interfaces on the system. So we see ENP 5S0 with 110 VLANs on it. We can see a second physical interface called ENP6S0, which just has the 100 VLAN on it. So that's like the physical interfaces. BR-int is something that's managed by Oven that we can ignore. LXD Oven, same thing. Guest VLAN is, in this case, the physical interface that we're using for that deployment. So if I do show on guest VLAN, there we go. We can see what's currently making use of it, what are the networks that are using it as an uplink effectively. We can see the DNS servers that are being set, and IPv4 and IPv6 ranges that are being configured to effectively be delegated to this LXD cluster. Now with that in place, if we go back to the project show that I did earlier, that Ubuntu LXD project is limited to only use that guest VLAN uplink. And it's got one network. If we go look at that particular default network, we can see that it's using, as its uplink network, guest VLAN, and then it's using private addressing v4, v6 on it. And its external addresses are recorded here in volatile keys. So we can see that it did pull an address on the parent physical network. And we can, the other thing we've done is instead of requiring you to input what the parent network is, what the uplink network is, if there's only one if there's either only one total on the system or there's only one that you can use through your project restriction, it just uses it by default. So if I create a new LXD network create test, this knows that I'm running inside a restricted project, so the only network type I can use is Oven, and the only uplink I can use is guest VLAN. Therefore, we've got a new network called test with a random IPv4, IPv6 subnet. It's pulled a new address from its uplink, both v4 and v6, and we see it using guest VLAN automatically. And it's obviously of type Oven. You can just delete it. The one thing we've implemented now on top of that, which we are still working on, so we've got the first bits, but not in a state I can really show with that particular test cluster, because we need a few more bits that are landing right now, is the ability to delegate subnets. So you might have noticed with that test cluster, we get as many private subnets as we want. That's nice. That means all the instances get an IP address and they get routed to the outside world, which is great. But that gives me no way to actually connect from the outside world into those instances because they don't have an external address. So that's what we've added. We've added the ability now to specify external addresses that can be used on a per project basis. And then those addresses can be routed to a particular instance. I can try to do some of the setup to just show kind of how that works roughly. But as I said, we're still missing a few pieces to get it kind of the way I really want it. So let's say we wanted to allow, I don't know, address 30 in that subnet to be used. So first we would need to tie it to a, I think we just need to tie it to the project. So we want to do project set. It's gonna need cluster admin because as an privileged user of the cluster, there's no way you can modify your own restrictions. That would cannot defeat the entire purpose of this. It's gonna be modifying the Ubuntu LXC restriction, Ubuntu LXC project, and set a restriction on it. So we want restricted networks subnets, and we're gonna be allowing just the one address. And we need to specify what the uplink is. So the uplink is guest VLAN. Right, and the other thing I forgot to do is we need to actually make sure that this address exists on the parent network. So in this case, it's guest VLAN, and we need to make sure that it has 4530/32. Okay, so now the parent network, if we go and look at things. So, okay, so my parent network, guest VLAN, which is of the physical type, has a route for that 172.17.45.30/32. Now I can delegate that to a particular project, which is what I'll do now. So that's now allowing the Ubuntu LXC project to use that particular address. And the last piece of this is that I can now let's add it. So let's stop one of the only have virtual machines in there. Okay, fine. Let's stop VM2 and we'll just add it to it. Okay. So we'll override the default device in there. So the network device is called DTH2, and do IPv4 routes. This thing. Okay. And we start it back up. And just wait for it to start. One thing that's worth noting here is that we are effectively delegating that address to. Okay, looks like it's starting up. We're delegating that address to that virtual machine. We are not. It doesn't become its own address. Like as in, if we look at LXC list right now, the VM still uses a normal private address, but that extra address is now routed to it. So in there, what we would normally do is something like this. It's 172.17.45.30/32, and then you stuff it on something like the loopback device. At which point it will eventually show up. Oh no, because I put it on the loopback device, it won't show up in the default list. That's normal. I think if I do info, it should. Yeah, we see it. 172.17.45.30. And because that stuff is an external cluster that's not properly routed and stuff, it does I can't actually show it pinging. But if there wasn't a big firewall in between, it would ping directly from here. By effectively having Oven respond to that address on its uplink network and then forward it all the way to the virtual machine so that it can answer to it. So that effectively lets us now do two different things. One is give one IPv4 per project or a few IPv4 per projects that are public and people can add to their instances to allow for ingress from the internet. Or if you've got a lot more addresses, which is especially useful for IPv6, you can get an entire large-ish subnet per project, say like a /56 or something like that, and then give, like on the network itself, instead of having the network use that FD42 private subnet with NAT, we can replace that with a full public IPv6 subnet and no NAT, giving every single instance running on that network a public IPv6 address. So that's how we're going to be reconfiguring this cluster over the coming days. We're going to be switching it to having one public IPv4 address per project, and also having every single IPv6 subnets be fully routed and no more NAT. And that's really the last feature in LXD 4.7. So a bit of a shorter stream today because of that, but it's still quite a lot of features inside of just one LXD release. And as I said, it's going to be rolling out to users early next week. We'll probably be promoting it to the stable Snap channel on Monday. It's currently already available in Candidate. In fact, that cluster I'm running against always runs Candidate, so it should be running on 4.7 already. And if you look at the bottom there, it's running on 4.7. And just switching back to my local machine. And yeah, that's it. Really the main highlights for most users, I think, is going to be the USB pass-through to virtual machines, including the integration with Spice, which is really quite powerful. For those running clusters, especially restricted clusters, the new networking bits are going to be quite useful. And for anyone who's doing backups of containers and storage volumes, now being able to both export and import, as well as import under a different name, will be quite useful, because it makes it easy now to test your own backups by trying an import under a different name on the same system, just to make sure that it works properly and you won't have any problem at a later date. Alright, well, that's all I've got for today. So thank you for following along, and we'll see each other at some other point with a stream, hopefully in the next few days. Thank you.